Hey, Algebra 2. Here we are with 3.7, 3.8. Okay. 3.7, 3.8. We're going to be solving. Okay. This little mini lesson here from 3.7. More of an awareness thing. You're not going to have to do a whole lot with those. More of an awareness thing. Okay. So 3.7. The determinant is the difference of the products of the diagonals. Okay? So the determinant of this 2 by 2 matrix would be AD minus B times C, whatever's in those two spots. Okay? So let's look at this one with actual numbers in there. The determinant is 5 times 9 minus negative 4 times 8. So 45 minus negative 32 equals 77. Okay? So let's have you subtract the diagonals. What do you get? 3 times 8 minus 7 times 5. 24 minus 35. We should be getting negative 11. Okay, so it's basically an awareness thing of how to do it by hand. It comes in handy here with a little bit of the build-up in 3.8, which is solving systems of equations with matrices. The first thing we need to know is the identity matrix. When multiplied to another matrix, that matrix stays the same or keeps its identity. So for a 2 by 2, the identity matrix is 1, 0, 0, 1. Because when I multiply this matrix times this one, it won't change, right? Let's see why. So row times column, we get 1 times 5, 0 times 3. So it's just 5 plus 0, it's 5. Row times column, 4, 0. 4 plus 0 is 4. Okay, now the bottom row times the first column, 0 times 5, 1 times 3, it's going to be 3. Okay, 0 times 4, 1 times 2, 5, 4, 3, 2. All right, so the pattern follows that it's basically the identity matrix is a diagonal line of 1s with everything else 0s. So for a 3 by 3, you have a 1, 1, 1. All these are 0s. A 4 by 4, we'd have a 1, 1, 1, 1. See, it just keeps going diagonal like that. Okay. To find out if you have an inverse matrix, two matrices are inverses if their product multiplies together to be the identity matrix. So I think we have an example here. Let's see what happens. 3 times 1 is 3. Negative 2 times 1, negative 2. 3 and negative 2 is 1. 3 times 2 is 6. Negative 6, 0. Negative 1 and 1 is 0. Negative 2 plus 3 is 1. So, yep, we got that. How can I find an inverse matrix? So, to get the inverse by hand, if we have a 2 by 2, A, B, C, D, to do the inverse, we do 1 over the determinant times those two flip spots. These two switch their signs. Pretty crazy. Okay? Remember, the determinant is the product of the diagonals, or the difference of the products of the diagonals, AB or AD minus BC. Okay, so there's a lot going on right there doing this by hand. Let's see what you can do, all right? Well, we'll walk through it slowly together. So 1 over the determinant. So step 1, I need the determinant. Okay? Negative 1 times negative 2 is 2. 0 times 8 is 0. So I have 2 minus 0. The answer to the determinant is 2. Well, I need 1 over the determinant. So 1 over 2 times, okay, these two flip spots. So the negative 2 and the negative 1 flip spots. So negative 2 goes up top. Negative 1 is now down there. And then the 0 and the 8 just change signs. Well, negative 0 is the same as positive 0 is the same as 0. It's neutral, right? 0, so that doesn't really change. And this one flips to negative 8. And then we multiply that through. We'll get negative 1, 0, negative 4, negative a half. All right, that was not a lot of fun. Again, with matrices, it's not necessarily tough math, but it is just a lot of little things, a lot of steps. Ooh, let's check on the calculator. What? All right. So, like we do with a lot of things, before we teach you the shortcut on the calculator, you got to come to appreciate all the hard work that goes into doing it by hand. Now let's check it out on the calculator. Okay? Underneath the math button, x negative 1 in the blue should be written as matrix. So second matrix. Okay, there they all are. We're going to slide over to edit. We're going to edit matrix A. Okay, we want this to be a 2 by 2. 2, enter, 2, enter. And now you're going to fill in the blanks. So that top left one was negative 1, enter. It should jump you over to the right. That one was 0, enter. Bottom left was 8, enter. Bottom right is negative 2, enter. And then it tries to start you all over. Okay? Now we're going to hit second quit. Sometimes you can do it, sometimes you can't. It's just really weird. So because we're typing into a cell in the matrix right now, if I were to do this next step without quitting and going out, it's going to try to calculate the answer and put that answer in there. And I don't want that to happen. So we're going to push second quit, right? Second mode is second quit. Okay, back into matrix, second matrix. And we're going to keep it. Just hit enter. We're staying with names. Don't slide over to edit. Stay there with names. Hit enter. A, and then the inverse button, x negative 1. Okay, A inverse. Ta-da! Negative 1, 0. Negative 4, negative 0.5. Neat. Okay, let's go back to that matrix menu, second matrix. If we slide over to matrix math, go to that first thing is DET. What do you think DET stands for? Determinant. So I can do the determinant of, now let's go back into matrix. And when you want to use one of them, you standard names. So I want to use matrix A. Yep, and my determinant was 2. That's what we had over here, right? 2 minus 0 was 2. And then we had to flip it, 1 over, so 1 over 2. Cool, cool, cool. All right, so you can do a lot of this on the calculator. Who knew? Okay, how are we going to use this on the calculator? What are we going to do? So we're going to solve systems of equations with the calculator. So x plus 2y equals 9. 3x minus 6y equals 3. Here's what we're going to look at. We're going to turn this into like a set of matrices. All right, well, what you do is you end up peeling off the coefficients. So that's 1x, 2y, 3x, minus or negative 6y. We have to keep them in order, so xy, xy, and then x goes on top, y goes on bottom, and then my answer is 9, 3. And just like if you were doing a regular algebra thing, if you had something times your letter, you would do the opposite, right? You would do the inverse or the opposite. If it was times, you divide. If it was addition, you would subtract. You're going to do the inverse to it. So I got to do the inverse of both sides. And what's tough here is that because of the order mattering, we have to keep it on the left. We're going to try to go left. All right? So this is what your work would be like. Okay, you change it to a matrix. All right, and if you want to do just a box inverse there, or if you want to call this matrix A inverse, okay, because what happens is when you do A inverse times this, it cancels out. All right, and then we just have your inverse matrix times 9, 3. Okay, so stay with me here. So we got two matrices we need. So second matrix, edit. Our first matrix that we're talking about is a 2 by 2. So 2, enter, 2, enter. All right, fill it in. We got 1 in the top left, 2 in the top right, 3 in the bottom left, -6 bottom right. Okay, quit. Second quit. Matrix. Okay, we needed this one. Edit, we're going to go down to matrix B. Edit, and I need this is 2 rows by 1 column, so it's a 2 enter by 1 enter. 9, 3. Quit. Okay? So just look at those again. We have a 2 by 2 and a 2 by 1. We got 1, 2, 3, -6 typed into A. We've got 9, 3 typed into B. All right, so we're going to do the inverse of A times B. So keep names, A, inverse button, x -1, times second matrix. Keep it under names, go down to B, enter. A inverse times B, 5, 2. And that's your answers. The top one's X and the bottom one's Y. 5, 2. Okay. Let's have you try that process on your own. Okay, you're going to have to rearrange this a little bit. Make sure to keep it in the same order, X, Y, X, Y. Okay, let's see if you can do that process on your own on your calculator. Push pause and give it a go. Alright, so step 1 here was to get this on the other side. X plus 2y equals 0. Okay, so now I have 3, -1, 1, 2, times xy equals 4, 0. Okay? Now, if you want to just, for your work, just go like A inverse, and then down here, xy equals. That's fine with me. Okay? So we got to type these in. Second matrix, edit, 2 by 2, 3, -1, 1, 2. Second quit, second matrix, edit, 2 by 1, and that was 4, enter, 0, enter, quit. All right, now you're ready for it. Second matrix, keep it under names, A inverse times matrix B. Oh no, did we make a mistake? Let's see if we made a mistake. 3, -1, 4. That was a -2y. We brought it over, 1, 2, 0. Well, sometimes the best laid plans go wrong. That's what the problem was. Sometimes it doesn't come out perfect. There's probably a typo up here somewhere. But we got x equals 1.14 and negative 0.57. If you see the error, let me know. That was supposed to come out nice, but I must have missed a letter in there somewhere. This is probably supposed to have something else over here. It probably wasn't supposed to be a 0. But, alright. Now, let's see what you got. This is what we're doing in the next lesson, 3 by 3s. 3 by 3s would take so much time to do elimination and substitution, but 3 by 3s with a matrix, it's exactly the same process. Just goes like that. Alright? Let's see if you can do it. Let's see if you can take what we just did here with 2 by 2s and see if you can do it with 3 by 3s. Okay, so let's see if you can handle it. Let's see. What do we get? So we got negative 4, negative 1, 3, 3, 2, negative 1, 1, 3, negative 5, x, y, z, negative 9, 3, 29. All right, and we would do A inverse. Okay, so getting ready to type these in. Second matrix, edit. Oh, this is a 3 by 3. Negative 4, negative 1, 3, 3, 2, negative 1, 1, 3, negative 5. Okay, matrix, edit. Instead of a 2 by 1, this is a 3 by 1. Negative 9, 3, 29. Second quit. Matrix A inverse times matrix B. Ta-da! Negative 2, 2, negative 5. And if you see down here in the tiny little corner, we got the answers written down. Negative 2, 2, negative 5. Okay? So that's what we're going to be doing next time. You might have like one of those sneaking in there today. That's what we're going to be focusing on in the next section. So go ahead and give your homework sheet a glance, see what the problems are for today. Best of luck. Let me know if you have any questions. We'll see you later.